Hello, students. Welcome to our channel Chemistry by Simple Rajendra Shukla. Now, in this video, we again further continue with JEE 2023 Chemistry Solved Question Bank. We have already uploaded 2 videos so far. This is the third one. Let us begin. An interesting question comes here on our way. For the disproportionation reaction, disproportionation का मतलब समझ जाओ पहले बच्चों. फॉर द डिस्प्रपोर्शनेशन रिएक्शन यानी द रिएक्शन वेयर सेम reactant undergoes oxidation as well as reduction. Once again, I'm repeating, disproportionation reactions are those redox reaction where the same compound undergoes oxidation and the same compound undergoes reduction as well. As you can see here, this is cuprous which is given to you. 2 ions of cuprous are given, 2 cuprous ions. One of the cuprous ions becomes from +1 to 0, that is reduction. And another cuprous ion from +1 to +2, that is oxidation. So same cuprous ion is undergoing reduction as well as it is undergoing oxidation. Hence, this is an reaction showing disproportionation at 298 Kelvin. Further, the natural log K or log K to the base E, we have to find the value of K in this question. The data given to us is when cupric ion, cupric that is 2 plus reduces to cuprous, then this much volt is produced since there is positive sign produced. And when cuprous gets reduced to copper, 0.52 is produced. They have further given us the ratio of RT by F, which we will need in the numerical as 0.0259. So every information is provided in the question. This is a JEE question of 2nd September 2020, shift 2. Let us see how to solve. Now, first of all, what I need to understand is the formula which we can apply over here is, we know delta G naught is minus NF E naught cell. Everybody knows this formula. We also know delta G naught is from thermodynamics, we have learned, is RT natural log K, which is equal to this side minus NF E naught cell. As a result, this gets cancelled and we have natural log of K is N into F upon RT into E naught cell. So the first thing we want to find in this question is E naught cell. So I'm finding E naught cell. The very first thing we need is find E naught cell. That is this value. And I have to find E naught cell from these two information provided to me. When I write the first information, it tells cupric takes 2 electron. No, not 2, just 1 electron because it is becoming cuprous. So cupric takes 1 electron and becomes cuprous, and the voltage is 0.16 volt. And in the second equation, it is cuprous takes another electron and becomes copper and produces 0.52 reduction voltage. These are reduction reactions, and hence what we are getting is reduction voltage. What we are getting is reduction voltage. Now, what I want is, I want E naught cell for this reaction. Now, how to get this equation from these two? So as you know, the first thing we want here is cuprous. The first thing we want here is cuprous. And children, cuprous is in the second equation. It is on the same side. You can see it is on the same side. And hence, we will not do anything to equation 2 right now. We will not touch this 0.52 volt wala equation. We see next. Also, this cuprous, why we are not touching is this cuprous is in 2 equations. And if you remember, we have learned anything which is found in more than one equation, don't solve the numerical on that basis. So I'm just leaving it right now and I'm going to next. This is copper. Copper is in second equation and it is on the right side. I want it on the right side. So I will say equation 2 as it is. So when I want to find E naught cell from these two equations, I will say E naught of second equation as it is, no change, plus. Second thing I want is cupric. Cupric is in first equation. I want 1 and I have 1 only over here. But I want it on the right hand side and it is given on the left hand side in equation 1. So I revert 1. When I revert 1, I change the sign of E naught of equation 1. And hence I can calculate E naught cell as equation 2 voltage as it is, but equation 1 voltage I reverted to minus 0.16. And as a result, the answer that I get is 12 minus 6, so 0.36 volt. Now we go back to our this data. Natural log K is equal to number of electrons involved in the reaction is just 1. You can see here 2 to 1 is 1 electron difference and 1 to 0 is again 1 electron difference, which you can see here also 1 electron involved in each case. Into RT by F is given to me, but I want F by RT, so I just substitute it as 1 upon 0.0259 into E naught cell. I found 0.36 volt. So when I solve it, I get 144 into 10 raised to minus 1. So the answer is 144 into 10 raised to minus 1. That is the value of natural log K. आपको कोई log use नहीं करना है, आपको natural log K full निकालना है. So no need to use any log or anything. Answer is 144 and 10 raised to minus 1 is already given in the question. Let us see the next question, students. The heat of combustion of ethanol into carbon dioxide and water is 327 kilocal evolved. So very first thing, I make this equation. Ethanol is C2H6O and I am doing its combustion, burning in presence of oxygen. So 2 carbons are there. They give me 2 molecules of carbon dioxide and 6 hydrogen produce 3 molecules of water. And we know ethanol is a liquid, oxygen is a gas, carbon dioxide is a gas. And see carefully, the temperature is 27 degrees centigrade, which is 27 plus 273, which makes 300 Kelvin. And 300 Kelvin water will be in liquid state, because to transform it to the gaseous state, we want 373 Kelvin, and 373 Kelvin is not provided to us. So I am taking water in the reaction in the liquid state. Now this value which they have given me is at constant pressure, meaning I have been given delta H, that is change in enthalpy at constant pressure, 327 kilocalorie evolved. I want to find the heat at constant volume, that is I want to find delta U, which is at constant V. And we know the relation, that is delta H is equal to delta U plus delta NGRT, यहां से इक्वेशन का हम डेल्टा एन जी निकाल लेते हैं, विच इज products gas minus reactant gas. Product gas is only carbon dioxide, which is 2, and reactant gas is O2, but I have to still find how many O2 I need. So 2 to 4 oxygen here, 4 plus 3 in water, 7. 1 oxygen I'm getting from here, so I want only 6 more. So 3 O2 gives me 6 oxygen. So it's 2 minus 3, that is minus 1. So delta Ng value that I get is minus 1. Students, what you have to understand here very carefully is this state of water must be very carefully written, liquid or gas. Once again, I'm repeating, since it's 300 Kelvin, I have taken water in liquid state, because for water to become gaseous state or vapor, I need 373 Kelvin temperature. Now I'm substituting. This is 327 evolved. I want to find delta U. Delta Ng is minus 1. R, they have given me 2 kilocalorie. But since this is in kilocal, R they have given me in cal. This is in kilocal. So I'm converting R to kilocal by multiplying by 10 to minus 3. And temperature, they have given me 27 degrees. That is 300 Kelvin. As a result, when you solve it, delta U value will come 326,400 cal, that is 326.400 kilocal with a negative sign. So this much is evolved. So I hope the question is clear to everybody. Let us proceed further with the next question. The major product in this reaction, okay, we are jumping from physical chemistry to organic chemistry. Fine, that's not a big deal. See, we know that this reagent is nitrating mixture. And this nitrating mixture will carry out electrophilic substitution by replacing H plus of benzene by NO2 plus, that is the electrophile produced from nitrating mixture. Now the most important thing is where that nitronium get substituted, whether it will get substituted at this ortho, this meta, or this para position. That is the question. Now, we know the substrate undergoes nitration reaction, that is aromatic substitution electrophilic reaction, that is ARSE2, that is substitution electrophilic, or in the aromatic ring of the second order. The electrophile nitronium would like to attack benzene nucleus at a site which is rich in electron density. सीधी बात है, this is an electrophile, so electrophile कहाँ attack करेगा? The site of the benzene nucleus which is electron rich. It will attack that site of the benzene nucleus which is electron rich. Now, positive inductive effect of substituent as well as sterical hindrance we have to check. Now we have got 3 already existing substituent. One is OH, one is NO2, one is CH3. Now you know of the 3 substituents, if you remember, priority order of the ortho, para and meta directing group, which is there in our JE book on page number 953. If you check that order, you will get that the ring activating order is OH greater than CH3 greater than NO2. And hence, we have to analyze the reaction from the point of view of OH. OH being a very good positive induction group and a very good ERG, electron releasing group or electron donating group, it is ortho and para directing and good activating group. Now the ortho position is sterically hindered between OH and NO2, but the para position is not that much sterically hindered, and hence the coming electrophile, which is NO2, will attack the molecule at the para position, because para position is less sterically hindered, and hence the reaction will take place here. So this becomes the major product. This is a question in your book, Alcohol Phenol Ether, in NCRT. Now we come to this reaction. We consider the reaction sequence given below. ठीक है, ये रिएक्शन दिया है. सबसे पहले सीधी बात है, हमें समझना है ये 3 डिग्री अल्काइल हैलाइड है. And a 3 degree alkyl halide, when treated with aqueous alkali, produces a alcohol. We have learned this. This is substitution nucleophilic of the first order. And when this same is reacted with this alcoholic KOH, alcoholic alkali, then we get an alkene, which is a E2 elimination reaction. It is beta elimination. So this is beta elimination. We all know that in first order kinetics, the rate is directly proportional only to the substrate, but in the beta elimination, the rate is directly proportional to substrate as well as the reagent. Now I want to find which of the following is correct. So let us read them. Changing the base from OH minus to OR minus. Changing the base from OH minus to OR minus will have no effect on reaction 2. Why not? Because reaction 2 depends on the reagent. You can see reaction 2 depends on the reagent, and hence changing the base will definitely affect reaction 2. Also, OR minus is a stronger base than OH minus. If I have a stronger base, then the E2 will be faster. So definitely it will affect the rate of reaction. E2 will become faster. B. Option B. Changing concentration of base will not affect equation 1. I mean reaction 1. That's true directly. Blindly, we can say it's true because SN1 is independent of the concentration of the reagent. So blindly, that's true. Next, doubling the concentration of base will double the rate of both the reactions. No, it will not double the rate of both the reactions because reaction 1 is independent of the concentration of the reagent. C, changing the concentration of base will not affect reaction 2. That's again wrong because reaction 2 depends on the base. So we got the answer B is true. Let us move ahead. So the most mind-blowing question comes. Two compounds A and B with same formula C3H6O undergo Grignard test. Yes, C3H6O, it undergoes Grignard test to give product C and D. ये देख के क्लिक हो जाता है C3H6O यानी कि एक प्रोपेनॉल है और दूसरा प्रोपेनोन है. ये तो इधर ही दिमाग की बत्ती जल जानी चाहिए. Propanol with Grignard. Now aldehydes with Grignard give primary alcohol. तो प्रोपेनॉल में ऑलरेडी 3 कार्बन है, एक और ग्रिग्नार्ड का जुड़ेगा तो प्रोपेनॉल will make primary alcohol, that is butanol. Okay, whereas acetone with Grignard gives secondary alcohol. No. ketone, no. Propanol will not give primary alcohol. In aldehydes, only formaldehyde gives primary alcohol with Grignard children. Propanol will give secondary alcohol with Grignard, and propanol secondary alcohol, that is butan 2-ol. Once again, I'm repeating. Formaldehyde with Grignard gives primary alcohol. Higher aldehydes with Grignard give secondary alcohol. And propanol is a higher aldehyde. Ketones with Grignard give tertiary alcohol. कीटोन ऑलरेडी हमारे पास एसीटोन है. एसीटोन में एक कार्बन और ग्रिग्नार्ड का लग जाएगा और मुझे टर्शियरी अल्कोहल, टर्ड ब्यूटिल अल्कोहल मिलेगा. अब कौन सा अल्कोहल कौन सा टेस्ट देता है ये मुझे समझना है. पहले मुझे ये समझना है ये ब्यूटान 2-ol है, सी. और दूसरा मुझे ये समझना है कि जो डी है वो 2-मिथाइल प्रोपैन 2-ol है. पहले हम अपना डेटा रेडी कर दें, हमने क्या क्या ढूंढा है. ये दो चीजें हमने ढूंढ ली है. अब नेक्स्ट जो हमें समझना है वो ये है कि कौन कौन सा टेस्ट देगा. ब्यूटान 2-ol सेरिक अमोनियम नाइट्रेट टेस्ट, जिसे कि कैन भी बोलते हैं, कैन इज गिवन. ये जो ब्यूटान 2-ol है, सेकेंडरी अल्कोहल का कलर येलो से रेड हो जाता है, येलो टू रेड इन दिस टेस्ट, और टर्शियरी भी येलो टू रेड देता है ये कलर. लूकस टेस्ट आपको याद है, सेकेंडरी अल्कोहल थोड़ा स्लो रिएक्ट करते हैं, टर्बिडिटी आफ्टर 5 मिनट्स, ये भी करेक्ट है. और टर्शियरी एकदम झटपट फटाफट रिएक्शन देते हैं, टर्बिडिटी इमीडिएटली. Iodoform test is given by only those compounds which have a methyl keto in them or which on oxidation give methyl keto. तो अगर आप देखें सेकेंडरी अल्कोहल में मिथाइल कीटो नहीं है, लेकिन आपको अच्छे से याद है कि अगर सेकेंडरी अल्कोहल का ऑक्सीडेशन किया जाए तो कीटोन मिलता है, और अगर ये सेकेंडरी अल्कोहल का OH सेकेंड कार्बन पे है तो सीधी बात है मिथाइल कीटो बनेगा. बट टर्शियरी अल्कोहल ऑक्सीडेशन नहीं देता है, इट इज रेस्ट्रिक्टिव टुवर्ड्स ऑक्सीडेशन. उसका स्टेप 1 में डिहाइड्रेशन हो जाता है. यानी कि हमारा ये जो आयोडोफॉर्म टेस्ट है ये भी सही है. सेकेंडरी अल्कोहल विल गिव बट टर्शियरी विल नॉट गिव, and hence C is butan 2-ol while students D is 2-methyl propan 2-ol. That's all for today, students. Be connected, keep on watching these lectures which we are conducting, which I am conducting daily. Take them seriously. It will be of very great help in boosting your scores in JEE 2023, and they are very helpful whether it is Neet, CT, VIT, SRM, whatever. Just keep watching. Bye bye. Love and blessings to all of you.